We have a very nice collection of engineers here. We have some engineering professionals. We have some engineering students. We have some engineers that live on the East Coast. We have an engineer that lives on the West Coast. Matt, I don't know, where do you live, Matt?
Just outside of Raleigh.
Okay, so still East Coast.
Yep.
But we're still coast to coast because of Dana Day. So it works out perfect. And I do have to say that extra props to Dana, because she is on the West Coast, so she is getting up much earlier than everybody else to be participating. So nicely done. Good job on that one. So we'll start. It's sort of a classic question that I've started most of these with, so it's a fair one for today. If you wouldn't mind introducing yourself briefly, telling us a little about what you're studying or your employment, and maybe like a 30-second before and after, like 30-second to a minute of like typical day for you pre-pandemic, and then 30 seconds to a minute typical day for you post-pandemic. And I have absolutely no preference who starts first on this.
Sure, I can give it a shot. Hopefully I got everything there, but yeah, I grew up in the Pittsburgh area, went to Pitt as an engineering student. I've been with my company now, Eaton, for about 10 years. Been in engineering roles from electrical engineering to mechanical engineering to industrial engineering, and actually now I'm in a kind of product marketing role. So it's actually a good segue between the two. Typical day, I actually work in a manufacturing plant. So there's a lot of employees there, about 600-700 or so. We're able to, normally it's a typical day, you go in, check base with the team, see what's going on the manufacturing floor. Typically we work on developing things for, next year or upcoming product launches and what have you. And then after that, we're typically also working with customers as, new applications are coming in, maybe an opportunity to work on a new project that might be, coming down the road for an end client. And then outside of that, it's, handling day-to-day emails and whatnot. So a lot of back and forth. Since being home for a little while, it's been, kind of adjusting a little bit off that. Obviously, in my role, I'm able to work remotely. So it allows me to kind of still keep up to date with things going on in the plant, still able to work with customers. We've done a lot more effort to do virtual meetings and things like that. So it's been a good effort there. But outside of that, it's been pretty good to try to maintain that type of interaction.
Okay. Can you say real quick, what do you guys produce in your factories? What do you guys make?
So we make motor control centers, and as best I could do to describe it, it's, I would say it's an appliance for the industrial world. Typically in your house, you might have a microwave or refrigerator or dryer. When you're in the customer that's trying to produce cheese or at a major refinery or a chemical plant, you don't have all these appliances. So you have to connect and distribute power and control that equipment from a lot of big scale electrical equipment. So you might have a load center or a panel in your house where all the breakers turn on and off. We have a much bigger cabinet that has multiple things that operate devices. So much bigger scale.
Yeah. Awesome. Thanks, man. I appreciate that. Cool. All right. Who's next in the queue then? Who wants to? Okay, let's make sure. Okay, you're in, Dana?
Yep. Hey.
Hey.
So I'm Dana Day. I'm a 2004 graduate from Norwin. And then I went off to Penn State main campus to learn about aerospace engineering, which set me up pretty nicely to go into my work at Boeing. Been at Boeing for about 12 years.
You know Matt when he was a student here? I feel like you guys are around the same.
I graduated in 2006. So I was a little bit later.
Right.
So I moved to Boeing out in Washington State, and been here ever since. Started on the factory floor fixing structural repairs, did some time as a flight controls design engineer, and then moved into more of a project engineer, project management role. So right now I'm a project engineer for the passenger seats that are on the airplanes, which I didn't know this was a job ever until I interviewed for it. And it's what I care about is the safety of the seat, that if you're in a crash, that the seat is not going to hurt you, that you'll still have legs that aren't broken that'll let you egress out and safely get out of the airplane. So pre-pandemic, I was doing about 5 international trips a year, going to like Wales and Germany to work with the seat suppliers, to get them meeting Boeing requirements and then FAA requirements and EASA requirements to build safe seats and suites. When you get into like first class suites, they're really complex, and they have doors and items that open and swing and move, and gigantic monitors. Just really fancy, top of the line, unique, bespoke items. So it's really cool to work on something so fancy, would be a good word. And then post-pandemic, I get to work from my home and just have a ton of online meetings. I think it's been challenging when you're not in a face-to-face environment, and because a lot of the suites are so unique, they don't have a lot of standard history or answers to pull from. So it's hard not being in that face-to-face environment, asking other engineers if they've run into something similar. So it feels a little bit slower getting work done and communicating. So it's been a big adjustment on that front.
Thank you. And then, so when you're designing the seat too, it's probably, you're saying you have to worry about the structural end of things, but you also, we can bring this up a little bit later as a more general question, but then customer like comfort also has to be an issue too, like in terms of like how comfortable the seat is and stuff like that. Like,
oh yeah,
do you have like equations for that? Or something? Well, no. I think. Look, before I I'll give everybody else a chance to speak. We'll talk. Somebody remind me that I want to ask about like the idea of trade-offs in engineering, like the fact that you always have to be like, if you always have to have like 8 different things you're balancing and how to get all those things. Just remind me about that, Dana.
Totally.
All right, well, thank you, Dana. All right, David or Nathan, who wants to go next? All right, go ahead.
All right. Yeah, so I'm David. I graduated from Norway in 2018.
David would also like to state for the record that his sweatshirt is not actually purple.
It is not purple. It's actually Norwin. It's a Norwin hoodie. I don't know. You can see that. My sister also went to Norway, but so if someone pops up behind me, that
is she there right now? Is she in?
She is. Yeah, I'm babysitting for her kids. So.
Oh wow.
Yeah, if someone pops up behind me, she said she might say hi or something.
Okay, yeah, tell her I say hi. She doesn't.
Yeah, so I'm studying electrical engineering at Case Western. I just finished my 2nd year. So I guess pre-pandemic, my day-to-day was just going to class, I guess. I am being 2nd year. Most of my classes are now geared towards electrical engineering versus gen eds. But I still had a couple gen eds, so that's like a rough idea, I guess, of where you would be for those high schoolers. Plus labs. So for electrical engineering, that's mostly going into like, you get to work with, well, at least for me, I got to work with a group. And we basically just built circuits and then measured them to compare them between like the real world effects to our theoretical models. And then post-pandemic, our labs ceased to exist because we could no longer meet up. So yeah, a lot of that, I don't know, we transitioned a lot of that stuff to online work. And
Did they try to replace your labs with like the online simulators and stuff like that? I mean, I know there's a lot of like,
they did, but then it turns out that the online simulations perfectly match our theory.
yes.
um, funnily enough, yeah.
Yeah. So that's good. Has it affected, like, I know in college, like summer plans are important and stuff like that. Did you have anything planned for the summer?
Oh, yeah. Actually, I was going to have an internship at Carnegie Mellon doing, so last summer, I was working with the same people, the same group at Carnegie Mellon, and we did they were designing an accelerometer using this thing called MEMS, micro electromechanical systems. So it's just really small accelerometer in essence. And so this year we were going to go through and just start testing it. But since due to the pandemic, that's either been delayed, it's delayed indefinitely, we'll put it that way.
All right. And then I'd like to welcome Nathan. Nathan is not a Norwin alumni, but a friend of a Norwin alumni. So any friend of a Norwin alumni is a friend of ours. So go ahead, Nathan.
Yes, I am, for the record, a very close personal friend of Mr. David Liu. So yes, I am the same age as David. I'm a sophomore at Carnegie Mellon. My major is material science engineering, and I'm doing a computer science minor. Let's see, my day-to-day. I guess like David, I had a lot of labs. Also, my labs were not at all the same though. We did a lot of microscopy in the material science department. So like X-ray diffraction, scanning electron microscopy, atomic force microscopy. I had 3 lab classes this semester. It was awesome. And then whenever I wasn't doing lab science classes, I'd take either math, which was boring, or I was doing programming classes for my minor. So the transition to online was not too horrible for me, I guess, since I'm in the same time zone and everything. You know, all of my classes, or Carnegie Mellon gave us all Zoom accounts and then just had all of our professors stream lectures live and then record them and post them afterward. All of my labs, they just gave us sample data and then had us write lab reports anyways without actually doing the lab. Is there anything else interesting that happened with that? No, not really, I guess.
Has it affected your summer plans at all?
So actually, as it happens, it does not. I am planning on going to Maryland to work for my aunt at a government contractor, and they're considered essential work, so they're doing everything as usual.
Cool. Good. Well, good or bad, I guess, depending on your perspective. I guess that's fine.
Yeah,
That's
I guess.
Yeah, excellent. All right. Well, thanks again. Thanks for joining us today. We absolutely appreciate having your insight as well. And then finally, Rachel, how are you doing this morning?
I'm doing great this morning.
Okay.
Just to introduce myself, like I said, I'm Rachel. I just finished my sophomore year. I graduated with David in 2018. I now go to Penn State for industrial engineering. I have 2 minors also. The first one is in Six Sigma, which I wouldn't expect high schoolers to know what that is because other college students don't know what that is. In like a sentence, it's really just like a school of thought to make a process more efficient, which sounds like garbage potentially, but
just I see Matt's mouth when you said that.
Like, you can help me explain in a level that is applicable, but it's a lot of use of like statistics and stuff. And I still have to take most of the classes for it, so I don't have a super good grasp on it. He can help out as an industrial engineer. And then I have another minor in information sciences and technology, which is fun also, and that's where I do and sort of transitioning into like this semester, pretty similar to the other 2 college students. It's about half and half industrial engineering classes and then, you know, other electives and stuff besides that. And the switch to remote, I mean, I got off easy. I had at least 1 class that was online anyways. So I feel like I sort of was off the hook with like labs that are impossible to translate over. It could have been a lot worse, to be perfectly honest. The thing that was probably the worst hit was that I was in a research program where we were, before spring break, we sort of did some pilot testing where we're just basically, it was like a wearable device was the thing that we were working with that particular day. But the whole semester, I basically just got to work with the design development for like a variety of assistive technology for blind people. The research was in information sciences and technology. It was very cool, and I could talk about it like a whole lot. But that sort of got snubbed because we were supposed to do like actual human subject research with, like, we had a couple of actual blind people who were going to come in and test our designs, and then obviously that sort of was unable to happen.
Right. Right.
So that was the first post-pandemic. And then as far as this summer, I was supposed to be doing a totally different research project this summer at Penn State, at State College. And that has turned into, I still have a job, but I'm working from home. And they figured that out like yesterday, so I don't have a lot of information.
Fair enough. Fair enough. All right. Well, again, I appreciate the diverse selection of people we have here, and different stages of their careers and studies and different fields, and again, I think it makes for an excellent conversation. So, in discussing with Dana earlier, we'll just sort of hop right into it. I think no matter what engineering field you're going into, probably one of the dominant themes is the idea of being pulled in a lot of different directions, having to satisfy a lot of different requirements, both within the device that you're working with or the procedure that you're developing, both practical concerns and economic concerns and things like that. So, and I know, David and Nathan and Rachel, you guys are a little earlier in your studies, and I'd be curious to see if they've talked with you about it in your curriculum. And then Dana and Matt, you guys have been living it for a decade. So to boil it down, I guess the question would be, how do you manage competing demands where every demand wants its needs to be met, but it's impossible to meet everybody where they want you to be? So, or I guess let's summarize that. Where does compromise come into play? That's probably a more succinct way to say it. Where does compromise come into play when it comes into engineering design? How's that?
Me go first?
If you'd like to. You've got the floor. Go ahead.
I know you're eager to hear about seats. So, so when the seat designer is actually the supplier, the supplier has a contract with the airline customer. So the airline customer has this amazing idea of what they want their whole airplane to feel and look like, and their passenger experience is number one. Number two is like flight attendant interaction with the suite and how difficult or easy it is.
Now, can I interrupt real sweet? When you're saying suite, is it like literally a tiny room in the?
Yes.
Like,
imagine just like walls around a seat.
So it's like a little it's like a little amusement park ride where they're like going into like a little ride basically, but it's like inside of an airplane. Like the door closes and they like sit in a little capsule basically. Is that like?
Yeah.
Okay. All right.
Pretty much. Very nice. I mean, you just imagine just thousands of dollars are going into this like one suite. So I come in and I say, well, the FAA and Boeing and EASA have all these requirements that you have to meet. Are you designing the suite to meet these requirements? And they have to balance between what I say they have to do and meet and what the customer, the airline customer, wants their suite to feel and look like. Something really simple would be like placarding. So when you're in the airline seat and you're looking at the seat in front of you, it probably tells you to fasten your seatbelt or where the life vest is. And when you get into a more complex suite design, there's a lot more placarding to tell you to close and latch compartment doors and do a whole bunch of other different stuff. And airline customers do not like placards. And then I come in and say, well, we need this because they need to know where their life vest is, and they need to know to stow this because it needs to retain items of mass. And so there's always this battle of, for something so simple of directional placards to tell the customer how to interact, or tell the passenger how to interact with their suite. So usually there's FAA requirements, and safety requirements are always going to be take precedence over this. And then if there's Boeing requirements, there's maybe some highly suggested, and then they're usually derived from an FAA requirement to bring in. So there's some negotiation room there, but anytime it affects safety, it's always going to take priority.
So you ultimately have the final.
Yeah, because otherwise we get a seat that we cannot certify, and then we cannot deliver. We can't put our stamp on and let it go out the door.
Now, Matt, as an industrial engineer, very briefly, that's Jing Liu. Hi, Jing. How you doing?
He said hi.
Oh,
You
hi.
can't hear them,
I'm
but
back.
We got Zoom bombed by David's older sister.
Zoom bomb.
You're not an engineer. You can't. You decided. What did you? Aren't you a pharmacist now or something like that? Or?
Yeah, she's a pharmacist. So
I mean, you work for the NIH, right? Still, right?
yeah, NIH still, yep.
Yeah, Jing. That's fine, but we're not talking to NIH pharmacists right now. Okay, that is. If you want to hold up one of your kids though in the background, that'd be fine too. We'd like to see your little kid.
Oh, unfortunately, the child is not at home at the moment.
What are you doing?
He's perfectly. Yeah, got special treatment for this meeting, so.
There we go. Excellent.
This panel.
Jing, I'd love to talk to you sometime about the work you do with the government, with the NIH. I'm sure COVID-19 has you busy, probably, right? She's not even listening. She can't even hear what I'm saying.
She can't hear.
Well, then translate for me, David. What are you there for?
I'm sorry.
Yeah, get in touch. We'll talk. Good to see you, Jing. What's it? Yay, we got Zoom bombed, everybody. All right. Matt, Matt, as an industrial engineer, your role is, say, very different than Dana's. So when what you're dealing with is more processes sometimes, and is your role different in trying to mitigate like compromise in what you guys do?
Yeah. So actually, I'll clarify. I actually graduated from engineering as a degree in mechanical engineering.
Right.
I actually minored in nuclear, and so it's been kind of interesting because throughout my career I found myself in a lot of different engineering disciplines. At one point I was doing mechanical design for products. At another point in time I was doing industrial engineering, and at another point in time I'm doing electrical engineering, and then now I'm trying to market it to work with engineering teams. So it's been interesting to kind of hear, as you talk, I think there is a common thread or mindset, around the constraints that we work through. And, even just kind of hearing Dana go on, those constraints are always, in the forefront of what we're trying to design something or work on something. Maybe it's a process standpoint, you're trying to reduce variation to, improve, quality and things like that. So, certainly those constraints are present in each phase. I think the more interesting part is sometimes that, a lot of those things that we identify as a problem statement and define, this is what the target is. There's always this point in time I can recall that you always are going back to revisit, are those constraints really valid? Because at different points of time, think that that's what the target is, and then another constraint introduces itself, and so you can be really tied in or cornered down. A good story I have kind of I think explains a lot of this. In an early part of my career, I had mentioned I was in mechanical design, and I was tasked with a project to create a component, and the application for it was actually in another part of our company. And you know, this little anecdote, you know, you spend all, you know, summer developing. We ended up getting a patent for our work. You know, spent all this time, you know, prototyping and all that. Fortunately or unfortunately, and I think more fortunately, years down the road, I actually ended up being part of the group that would have actually used that product. And at the time, you know, when you're first working on it, you're getting a lot of input from different teams. Yeah, design it this way or incorporate features like this, and that would be good. And, you know, I can remember that moment, you know, as I was working with the team, it was like, hey, could you guys have used something like this? And some of their design team was like, oh, that was you. Oh, come here. And so you're instantly, you know, fed a lot of that, you know, oh, this is how I would have done this, and you could see more of, you know, reality, what really was some of the problems you were trying to solve, and had you better known that. So I think, you know, that was, fortunately, I got that experience early on. Because it kind of fuels me now to, you know, in whatever role I'm in, for either working with a customer and, you know, they're trying to provide a solution that, you know, might be for a grain silo out in the Midwest, you know, collecting a whole bunch of corn, and you know, there's a desire for, hey, these are the kind of features and things we want to have. And really, you know, in a constant pursuit of, you know, really what are we trying to get at here, and really trying to understand, you know, the situation, and what sort of constraints are really there, or maybe what they really understood early on, you know, might not be so strong. I had experiences later on where, you know, we had to do a custom application where we had to incorporate a number of different features in there, but it all had to be in one box, which was a little bit atypical for the scenario. And we finally got a chance to actually get the end user on the line, and ask them, hey, is there any reason why this all has to be in, you know, this one form factor? And there was a pause, and I think at that moment, you know, everybody was kind of looking around, and it was like, well, I just thought it would look nice. So, you know, those, a lot of those things, I don't know if it kind of answers a
No, absolutely. Those are awesome stories. And it, you know, with what you and Dana both said, it also reminds me that, you know, from the rest of you guys who are in, you know, your studies still in college, you know, when Dana and Matt are doing what they're doing, I mean, they're working from rule books and regulations and stuff like that. But it's, I think it's interesting to note that both Dana and Matt sort of said, you know, what they're doing. I mean, they've got a goal where they want to be, but no one's telling them like what the right answer has to be. Like, they decide what qualifies as the right answer. And meanwhile, you guys, as students, I don't know if you guys, I'll make this a twofold question, I guess, depending on, first of all, is, you know, in your studies, do you have the opportunity yet? I know some of you are still a little early in it, you know, to really get in there and make some of these decisions yourself, or are you watching other people make those decisions? In terms of where these compromises come, or are you sort of told how to do it? That's question number one. And then question number two, like looking ahead to your guys' curriculum, is there, or maybe it's already happened, as a student, are you guys trained to make these decisions, like how to balance these different things? Or is it something that you think you guys are going to be expected to learn on the job? Twofold question to the students. So A, are you trained? Are you given an opportunity to experiment with making compromises in your designs? And two, do they formally train you guys on how to deal with customers and clients in the art of compromise design?
I can answer the second part real quickly, since I don't have much of an answer. No, we don't talk about customer interaction too much yet. I'm told there's a senior year course about it though, so we'll probably get there. It's a concern. Making compromises though, yeah, I would agree, seems like a really common theme, at least in my engineering discipline. Generally, any property that we want to improve, whenever we're engineering materials, for example, there's always some sort of price we have to pay. So if you want to increase hardness or strength, you're usually paying a price in ductility. And likewise, if you want to increase ductility, you're paying a price in hardness and strength. And then likewise in computer science too, from what I've seen, you know, in general, this is a massive oversimplification, but to make anything faster on a computer, you also need to make it consume more memory space, and vice versa. If you want to make it consume less memory space, you might end up needing to make it slower. So it definitely seems like engineering is a field of balancing those trade-offs in the most pleasing way for whatever it is you're trying to do.
And when you're doing your stuff as an undergraduate, you're just worried about the properties themselves. When Dana and Matt are doing it, they also have to worry about like cost as well. So that's, you layer cost on top of it as well, and you might find a really ideal solution, but the customer doesn't want to pay that much for it and stuff like that too. So I assume it only gets more complicated as you get up there. Thanks. That's a really great way to think about it, Nathan. David or Rachel, do you guys have any experience along those lines too?
Yeah, I mean, speaking on cost, like this semester, one of the first classes that they make you take once you're kind of into the actual industrial engineering curriculum, because it's like general engineering and then in the major is how they structure it.
Yeah, and Rachel, I'd say too, real briefly, could you give like a 45-second synopsis of industrial engineering, because it's a really different kind of engineering, and a lot of kids may not be familiar with what that actually means.
Yeah. So I thought about like the shortest way to explain, I guess, before, but IE gets like a lot of nicknames. Like I think that process engineering is probably the best one, where instead of working with like, one specific part of or piece of machinery, it might be like the entire process. A sort of classic industrial engineering job is where you're kind of on a factory floor and you're looking at how all of the parts of a process, like you watch like how it's made or whatever, and that whole, like everything from the beginning to the end, like an industrial engineer might like look at how that whole process works together to make it, better, safer, more efficient. Safety is a big part of it. That was another class that I took this semester where you basically just look at the process of what someone on an assembly line might do if they're putting parts together, or if you watch like one piece itself as it kind of goes through, the entire process of being incorporated into a design and basically make it better.
All right. So within the idea of an industrial engineering, like a process, like, a compromise might be, hey, if we allow worker X an extra 30 seconds to work on this part, we will, improve, the quality by X%, but it'll cost this much more. Meanwhile, if we trim it a little bit, the quality of the part's going to go down, but it'll be cheaper to produce. But we might even have a higher accident rate, for the worker and stuff like that. So these are all things that you guys are constantly balancing when you're thinking about.
Yeah, and I'd say, Matt, if I might add on to that, I mean, a lot of times too, you end up working with the same design teams that are developing those products, right? Because if the end goal is for those to be, produced in an assembly line, it's also an ability to kind of take feedback of, if a part is being produced, but has a chance of being put in backwards, how do you design the part so that it can't be put in backwards, or, kind of design out some features. So, there's good collaboration aspect in that. Also kind of understanding, if there's a sequence of operations for things to be done, and, watching how the workstation is laid out too. You might realize I'm trying to put a part over here, but I've got to go over to another area to, pick that up. And so it's, even trying to cut down on that cycle time, in just the way the workstation's laid out. So it affords a lot of different kind of problem solving thought processes, and you use a lot of different tools. Obviously certain things, if you can reduce some of the variation and improve some of the consistency, the end product will be a lot better as well.
That's good. Yeah, good. Communication aspects as far as that goes then too. So good. Rachel, did you have anything else to add as far as compromise training or anything like that in your specific coursework?
Yeah, I mean, it came up a lot, like this semester specifically. That's just why I'm like, oh, this is directly related to like at least two of the classes that I took, but a lot of it is also cost analysis too. That was a huge part. I mean, I had a whole class that was called like engineering economy, where really we just talked about comparing like different projects based on cost. And I mean, there's a lot of trade-offs related to that too.
All right. Neat. Thanks a lot. Thank you. And then David, in the more austere field of computer board, what do you say, David? Compromises?
Yeah. So we haven't really talked too much about compromises in my classes. I mean, it's been mentioned several times in several of my classes. We talk about like safety or cost. Those are the two big ones. And then convenience is also another one that gets brought up a lot. Like if, I don't know, for example, you can use 120 volt, 60 hertz power in your device, then that's great. In the US, then perfect, because that's what you get out of our walls, out of our outlets. Otherwise, then you have to buy like transformers or like an AC-DC converter, and that's all money. But yeah, in terms of like a course on that, I think we have a course that's called like communication for engineers. That's like a junior/senior level course.
What's so funny about that, Dana? I don't know. Dana started laughing at the title, but
that's a very relevant course. Engineers don't like talking to other people, and they will like head down, power through, design exactly what they want to design without talking to anybody else. So if you're able to communicate and talk, it gets you a lot farther. And yeah.
Like, sorry, David, go ahead. I just saw Dana like get a chuckle out of that.
No, that's fine. Yeah, so I guess some like specific examples I can think of that have been brought up in my classes just off the top of my head. So like for MRIs, I think they're held at about like their magnetic fields are about 0.5 Tesla to like 3 Tesla, something like that. And then some like there are ones that go higher, but that's like I think the general thing. But it turns out that's really expensive to like maintain. So those higher magnetic fields get more expensive to maintain because you're keeping a lot of power running through those machines. So that's a cost factor that ends up that has to be like taken into consideration. And on like the other end with like really small things, in my semiconductors course, we're talking about how computers, it's really hard to make chips smaller because then you have effects like tunneling, like quantum mechanical effects start taking like precedence, and like tunneling happens. And so you can't make things too small or like it doesn't work, or also you have to like change kind of some of like the fundamentals of how computers are made. So it's like then the money has to go into R&D. So there's stuff along those lines that ends up having to be made. Safety, it's been mentioned, but we haven't really
we need to worry about that, David, right?
Done much about it. Like I know 120 volts, 60 hertz through your body, probably not healthy. But other than that, I'm not really sure like what the cutoff is there of like like you can touch two ends of a battery and you probably won't die, but stick a fork into a plug, probably not your best move.
High level research at Case Western here.
Yeah.
Tuition going to a good purpose there.
And then I guess like in terms of convenience, so I had a design project for one of my circuits classes this semester, and so they pretty much told us, using everything you've learned from this past semester, build a 3-stage amplifier with these parameters. And so I guess typically would have done that in a lab with like actual parts that they had in the lab, but instead they just said, here are the things you can use any resistor, but you can only use 3 transistors, and like these are the specific transistors we want you to use. Go at it, right? And so so I guess it's more open-ended. It was, I mean, given the stuff that we were given, there was only like a few possible routes you could have taken, but it was still like a more open-ended type of project where they gave you parameters and they give you a goal, and then you have to go complete it.
Yeah. And I would say if there's high school kids watching, the idea is that a lot of times when they're solving problems, there's pretty much one way to do it. you set up the initial information. So it's a lot more linear than that. So when you get to college, you get a little more flexibility, and then when you're out in the real world, it's Bob's your uncle. You can do anything you want to. So it's I tell you what, as since we have 2 veteran engineers here and we have 3 students here, I tell you, veteran engineers, can you recall a sort of an experience that you had as an undergraduate that was kind of like a defining, like very stereotypically engineering student experience? And then we'll bounce that off these guys and see if they've experienced it themselves yet. Like anything, like it doesn't have to be like field specific, but just like there's got to be like things that happen to you as like an engineering student that's like classic engineering student shenanigans or problems that we'll see if these guys have experienced this stuff yet, or maybe they still have to look forward to it.
So I think one of the first things that comes to mind is even going back into a lot of the high school science and math classes. What you'll see in an engineering curriculum is typically, I think as David was mentioning earlier, is that you spend first 2 years in college kind of working through a lot of your background science and physics and all that, and you're solving all of these problems, but you have no idea what you're solving them for. And then you get into kind of that second half of your college curriculum where you're into the material science or mechanical engineering, and you're actually seeing what all those helpful equations were really utilized for. So you're spending all this time prior to that working on differential equations and things like that, and obviously there's a lot of principles and understanding, and I remember struggling through that, just what is this actually utilized in, and then you go and you're trying to find out in your second half of engineering career, maybe your junior or senior year, that you start seeing more of those. You've got a problem now where you're trying to design a wall or something like that has more conductivity, and oh, by the way, it uses that same equation you were trying to learn. So it was that reminder that, oh, I should have did better back at that point. But
real quick, are all 3 of our students? Are you guys all sophomores this year? Are you guys?
I think we all completed our sophomore year.
Okay, so you guys, so they're right at that. Do you guys feel that what Matt said is that you spend a lot of your time on book learning right now, and you're looking forward to your classes next semester, or maybe in the fall? It's finally going to start transitioning more project based and more hands on and applications. Does that seem reasonable?
Yeah, actually, I had a class that was sort of like that already, like just this past semester, where they pretty much said, or like most of the class was, here are these equations that you've talked about, or at least seen, and then here are a bunch of applications for those equations. And it was kind of like there was a lot of topics, so they just kind of breezed through a lot of them, but it was pretty interesting just seeing how these equations that we've just seen as like letters on a page be translated into, or like see how they're used in the real world.
I got dogs in the background, but Nate or Rachel, you guys want to jump in on that? You guys feel you're about to transition into a world of a lot more application, looking at your curriculum coming up?
Yeah, pretty much.
Yeah. I sort of like started already. All my classes are out of order based on the recommended schedule, I guess. So it's a little more complicated than that. But yes, in short.
Good. So Matt says you have something to look forward to in the fall, assuming you guys go back to campus. Dana, stereotypical engineering student experience, and you're curious as to whether or not, X number of years later, it's still the same deal.
Maybe I'll take it in a different direction. When the most valuable part of college was just trying to find out what I was passionate about, what my interests were. So taking advantage of like all the clubs, all the opportunities that it poses, like waking up early on Saturdays to go do engineering workshops for Girl Scouts. And it turns out I really like that stuff. And alternatively, you could just sleep in and miss it. So I think for me, the college experience was very much testing out the waters in different clubs, finding my passions, and then finding a group of study group partners to rely on and help share our knowledge and experience so we can kind of get through it together. Because while engineering school is pretty hard, it's also pretty rewarding, the opportunities that you're able to take advantage of.
All right, so I'll bounce it back to our students then. So I'd say within Dana's answer, which was very well spoken, I'd say there's sort of two aspects to it. The role of extracurricular activities outside of your just regular, mandated syllabus, and then the role of a good study group. Is that still both active and present in the life of an undergraduate? Do you guys have any opinions on the role of extracurriculars and or study groups?
Yes.
Yes.
I have a strong opinion.
I have an opinion, yes.
So as far as extracurriculars, I did a lot of them my freshman year. I know there are 5 billion clubs, I swear, on campus. I don't do so many of them anymore because I decided that I preferred to just cram my schedule with as many classes as possible. And I was okay with not joining clubs to do that because I figured club stuff is mostly for fun and I can do that anytime, but I can only pay $50,000 a semester for classes now, so I'm going to maximize my credits per amount of money spent.
That's right. Graduates, opinion of what Nathan said. Do you agree with him that he should cram as many classes in? Because again, CMU is not free.
I do agree that college is very expensive. And I've talked a lot about my experiences in different leadership camps or opportunities like that, where I was able to demonstrate that I led a team, even as a undergraduate. Whereas if you're not involved, it's hard to get that same experience. There's some like research avenues that you can take where you work in teams. And again, the idea of compromise comes in, and learning how to pull together different requirements and different team members' points of views into one cohesive statement. Like that's leadership too. So as long as you're looking for opportunities to make yourself well-rounded and learn, then it's all good.
Yeah, I will admit my situation may be a little bit unbalanced. But then answering the study groups part, I've definitely found that within my major, it's very small. There are like 30 of us. So we have a gigantic Facebook group message that is just all 30 of us. And I found that to be extremely helpful because often there are a lot of things that you don't see the answer to instantly, not because you're dumb, but just because different people happen to notice things at different times. And having a group of friends who are all taking the same classes as you, or just, having a group of friends within each class that you do all your work with is very, very helpful to getting your homework and your projects and your assignments done in a normal amount of time instead of wasting a bunch of time banging your head against a wall, looking over and over again at the same thing. It was actually really simple and you just needed a little nudge. So I've had friends who every time they come into a new class, the first thing they do is start asking people, hey, do you want to make a group me or a Facebook group or something for this? And I think that that's a really good thing to do, and working with other people on things is good.
Yeah. I would say I'll add two things real quick, and then I'll get Rachel and David to me. I would say I've heard from a lot of people, Nathan, that several engineers have told me that you should always try to do at least one thing, like one afternoon once a week, just to get out of all the engineering stuff and just do something totally different. And I've heard that independently from so many people, and it just gives you a chance to stop being an engineer for an afternoon. And then I heard that's healthy. So, and I would say, from our senior engineers, I would say for our students right now, probably the biggest thing that's different than when you guys went to school is just the fluidity of online communication, and the idea that
we didn't have
instant,
any Facebook groups.
Yeah, it's like instantaneously sharing information on a scale that you guys could not have imagined when you were and it wasn't even that long ago, but it's just great. It's like ubiquitous knowledge, everybody knows everything instantly because everybody just puts so it's a very different environment as far as that goes. But I'll give David and Rachel, I'm looking at our clock, I'll let David and Rachel finish up on that, and I don't want to keep you guys because I sort of committed you for a window. But David and Rachel, so study groups / extracurricular.
Yeah, I mean, for my philosophy with the extracurriculars is kind of different. I mean, going into next year, my biggest extracurricular, I don't think that I could really get further from engineering or STEM because it's actually like if any of you guys do Model UN at the high school, it's basically that. Mm-hmm. And that's where I'm getting like my leadership for, your resume, gotta have it, I guess. And I like that it's very, very different from all of my coursework. And it sort of is an outlet for, just to be a little more well-rounded. That one sort of has the bonus that it's just gets you to practice like public speaking. I mean, I just sort of like that stuff. I know some people really hate it. But that's sort of where I am, is to just, whenever I'm not doing engineering, I'm doing something completely different. And then study groups. I mean, we've sort of organized ourselves that I have a group chat of people from all different disciplines. It's not really based on class, but the way we do it is just so that we like see other humans from day to day. You're not just in the library at a desk like alone. Is every time someone says, okay, I'm going to sit at this location for a couple of hours, then they just drop their location. And then other people, like we just kind of moved around campus as a pack, basically.
Yeah. Oh, that's awesome. So cool. That's excellent. And David, what about you? Way over in Cleveland?
Yeah, way over there. Yeah, there are honestly so many extracurriculars depending on what you're looking for. Especially, I know at Case, I'm fairly like 99% certain at every other university. There's extracurriculars for like absolutely everything. There's also club sports, varsity sports. I know there's pretty much for every major, they have their own club of some sort. There's like robotics teams. I know there's a club that does like remote controlled vehicles. There's one that does bridge building for this, not out of spaghetti, I'm pretty sure, but out of other materials. There's debate teams. There's everything, honestly. And
but what do you do, Dave?
What do? I joined the robotics team for a little bit, and then it turns out it was way out of my depth. So I quit for like a couple semesters, and then I'm going to see if I can go back now that I know a little bit more.
Right.
But it's also really nice just to be able to apply some of the things. Okay. If you go to something that's like related to your major, applying things that you learned.
Okay.
And in terms of study groups, my study group for my gen eds ended up changing because a lot of them were just not in my major. So then my like lab group from last semester turned into my study group. Mm-hmm. And it's pretty nice, especially once you realize like everyone has different strengths. If you haven't realized that yet, but like everyone has different strengths and like especially on different scales. This is kind of tangential, but I remember back in my internship, like last summer, whenever it actually happened, with like the electric mechanical systems, you get these like grad students from the electrical engineering side and the mechanical engineering side, and they're all like working together and like asking each other, well, like, what do you think? How would you do this? Or how would you do that? And then putting their skill sets together in order to try to accomplish whatever they're trying to accomplish. So just having multiple people to bounce ideas off of, in general, is really
very
nice.
Very social as far as that goes too. And I would say again specifically for like Rachel and Dana and Dana, I'm sure you can back this up better than I can with your involvement with Society of Women Engineers. There's a lot of studies that show it is super important for women who go in engineering to get involved in groups with other people too, because a lot of research shows that if a male student fails a test, they just sort of accept that's, it happens, and they're like, it's like, whatever, I failed a test. But, a lot of time female students take failure more personally, and instead of just sort of bouncing back from it, they question whether or not they're supposed to be there or not. So, the role of a positive group for female engineering students is important to keep that retention up there. Is that something the Society of Women Engineers sort of backs up as far as that goes? Am I
Oh,
misquoting?
absolutely. And additionally, it's a very safe place to try and fail, because it's hard to learn how to fail. So when you have a safe environment or a safe group where you can try new things and speak up, it's all good for confidence.
Okay, excellent. So, all right. Well, I tell you what, I had you guys booked to 11. Can I wrap up with one sort of closing question? Would that be, and if anybody has like a work meeting at 11, I totally understand. David, if you have to go and make a peanut butter sandwich for the as of yet unseen children, that's fine. I totally get that. That's you can start cutting some crust off for some sandwiches. All right. So we'll go 30-second elevator pitch as to why someone who's watching this video who is on the fence should consider engineering. But before you say that, preface it by acknowledging a challenge that you faced that you weren't necessarily expecting you were going to have to. So start off with a challenge that you faced that you weren't necessarily expecting you'd have to. And that could be like professionally, as a student or in your career. But then wrap up on a positive note with why they should do it anyway. How's that? That's simple, right? So a potential obstacle or an obstacle that you faced, but why it's worth it anyway. How's that?
I can start, I guess.
All right.
So the one that I think, and everyone talks about I guess the classes are hard, and that didn't really deter me in the beginning, but sort of the most unexpected obstacle for me was, and they say okay, here's how you get an internship, here's how you get a job, and you attend all these workshops, and they tell you okay, here's all this stuff that you should do and that you should have on your resume. So I do all those things. And then the hard part is actually going and seeing recruiters and looking at them and talking to them you're a human and they're a human. That is the worst for me. I just, the one-on-one is something that I struggle with personally so much. And obviously it's worth it and it's uncomfortable, but it gets better every time. And especially this past year has been where I don't know, a semester plus of me saying, oh no, I need an internship for summer. Oh no, I have to, interact with these recruiters in addition to having all of the stuff, textbook, I need to have all of these things lined up for someone to want to hire me. And it ended up being very much where I had an opportunity last year to do a study abroad. I don't want to rub that in anyone's face that I was able to travel. I know that we're not able to do that right now.
David's turning purple with envy right now.
Oh boy. And one of the professors that was there with me ended up being the person that hired me for my job this summer. So it's just take advantage of everything. You'll be okay,
Okay. So even though it's kind of hard to get yourself out there, the results of getting yourself out there can be very, very positive.
Yeah.
So, and I will add, and then Dana could add to that too. I know Society of Women Engineers does offer, at least I've seen workshops where they offer training for interviews and stuff like that, and they do a lot of outreach programs to get undergraduate women ready to go for that process too, right? Am I right on that?
So much. There's a women in engineering program.
Yeah, and even at your colleges, I know mine had a strong co-op and internship office where they do mock interviews and resume reviews. So there's a lot of resources available to college students to take advantage of.
Cool. Well, thanks, Rachel. That was a really well-rounded answer. Thank you. So who's next? Who's next on the?
I'll give it a shot. Rachel kind of had some good points there. I think growing up in the Pittsburgh area, I always thought, that would be the kind of hometown, you'd be around there. And I think, as you're going on and, going through engineering school and starting your careers, there's a lot of that, open question on, where am I going to live? Am I going to still be in that area? And, in my time, I've been able to, work in both North and South Carolina, work out of, Chicagoland area for a few years. And, I think right now I'm in my 10 years, I've been able to touch about 40 out of the 50 states. So, but growing up, I don't think I would have ever imagined that. You know, your biggest commute might have been 30 minutes to the other side of town. And I think, you know, as a whole, you know, personally, you know, you kind of look at that as like, this is the little world that I live in. And so, you know, growing outside of that, you know, can seem pretty daunting. And I think, having those different, whether it's groups or teams or people that, you know, you're going through engineering school that are all, you know, trying to, you know, establish themselves, you know, you're looking for jobs and things like that, you know, just always continue to kind of learn and grow. I think, you know, in the end, you know, kind of pushing myself outside to, you know, to move away from home, try to live, you know, on your own in different states, different areas, work in different, you know, places allows you to see a lot more than I think you would have ever had a chance to experience. Certainly kind of the professional societies, I'm part of the IEEE. So it's been able to kind of build out a network of different professionals that I don't know that I've ever had a chance to communicate with and connect with. So it really kind of challenge you to kind of, you know, push yourselves to, you know, go beyond what you think, you know, your limits are, because there's a lot more out there.
Awesome. Thanks, man. I appreciate that. Yeah, well traveled too. So we got East Coast, West Coast, and then North Coast, South Coast. Is that a thing? We don't really have North Coast, South Coast. That's North border, South border. Is the way that's excellent. Thanks, man. Do we want to hop back to an undergraduate for the next one? AKA David or Nathan?
Okay, I'll go. Okay, unexpected difficulty, I guess. A lot of the ambiguity, you know, you get to college courses and you talked several times about the fact that problem solving in college is a lot different from problem solving in high school. There is no longer one obviously right answer, and there's just a lot more uncertainty in pretty much everything you do. I know in high school, at least every time I ever took a test, you at least know how to start almost every problem on the page because you've done very similar things. And now some of my exams and my homework assignments get to be very, what the heck is this? I've never seen anything like this before. I think I might be able to apply this one thing that we did in class, but is it right? Because I've got no idea. And getting comfortable with the ambiguity was, I guess, one of the most unexpected challenge I've probably had, but it's still been very fun, and I think that's a lot of what the real world is like based on what people tell me. So I would recommend it anyways, even though it's a little uncomfortable.
Excellent. So despite the uncertainty on how to press forward, it's rewarding when you figure it out, though, when you get all the pieces to come together and stuff. Good.
Yeah, that's a good way to state it briefly.
If I paraphrase. So, all right, and then David or Dana?
Yeah, I'll go. So I think one of the challenges that I'm facing recently is what's called like imposter syndrome. So where I will find myself at a meeting and they'll be asking a question, and it's the engineer's responsibility to own that part of the question or the answer. And I'll be like, no one else is going to answer? Oh my gosh. Because I remember I'm the only engineer in the room. So the feeling of, oh my gosh, I'm not supposed to be here. I can't possibly know enough. But then remembering that I've worked 12 years to get to this spot, and that I know everything I need to know. And if I don't know, I know how to find it. So remembering that you've learned all this great information and it keeps on growing on itself to be exactly where you are. And that I have every right to answer the question as any other engineer.
And thanks for sharing that, because again, I think it's refreshing to hear that, you know, even though you're like 12 years into your career, it's still, you know, you still have questions about, you know, I guess a lot of times engineers are presented in society as these people that just are like, they walk in and they throw a sheet of calculations down on the desk and walk out and stuff like that. But it's you know, there's challenges and uncertainties, and it's okay to feel like you don't know everything, because you probably don't, but you can figure it out. And I guess that's the key thing. So awesome. Thanks. Imposter syndrome, is that what it says?
Yes.
I feel like that's a good David, write that down. That's a good band name for your garage band. So write that down. Go ahead, David. Let's wrap us up. What do you got?
Yeah. So along with like recent challenges, I think I guess I've been pretty fortunate that most of my classes I've had like pretty good professors or like pretty understandable material within the courses. But eventually, I think everyone gets to that point where either they just have a terrible professor or, I mean, okay, there are different classes and different learning styles.
You're being recorded, David, so just be
And
general.
yeah, right. And so like some professors might be super conceptual, or some professors might do some hard derivations where they just go line by line, equation by equation. And you're like, well, what are they doing? I don't even understand why they're taking these steps. Or on the other side where they say, here's equation 1, here's equation 2. That's an exercise for you to figure out how they're related. And you're like, what? But I don't know. This just being something that like I really enjoy doing, and just having to put, I mean, sometimes you might just have to put more time into it, but I really like what I'm doing. I really think it's fun, or at least it's really interesting. Fun might not be the right word. It's really interesting, and like I'm really engaged with the topics that I have to like learn about, and I don't know. I'm willing to push through some of these challenges, and I'm sure that that's just more skills that end up having to that I'll use in my career dealing with like people maybe that have just a different perspective on how things should be done.
Okay, that's probably fair. And again, yeah, and again, Case Western and is a very very blue ribbon school, but it's refreshing to hear that even there, it's professors can be challenging. It's and I think everyone here can probably agree with the idea that the ability to communicate with other people who are everyone is confident about what they understand to be true, but making sure everybody appreciates everybody else's perspective as far as that goes. I've heard that in a couple other seminars throughout the time. It's just, the ever-present challenge is communication, making sure that you're able to understand what other people are asking you to do, and that you are able to communicate your own abilities in that context too. So I would say that's probably fair for anybody here to worry about. So good, well ended statement there, David. Good job. So, and I want to thank everyone for being here today. I thought it was a really great conversation. We had a super great spectrum of individuals, and even though you guys came at things from different perspectives, I think it formed a super well-rounded look at engineering as like a real job and not just some like movie role or something like that. So again, I absolutely appreciate it. And just there's Jing again. So all right, virtual applause to all of you. Thank you for your time. Outstanding.
Thank you for setting this up.
Oh no, it's my pleasure, David. It's my pleasure. Thanks. So we'll let the kids percolate in.
Percolate. That's a great word.
Oh, thank you, Nathan. Thank you.